Welcome to this video. In this we are going to discuss the ADC and DAC interface, analog to digital converter and digital to analog converter with the microprocessor. First let's have a DAC interface, that is digital to analog interface. In many applications, this microprocessor has to produce analog signals for controlling certain analog devices. Basically, the microprocessor system can produce only a digital signals. So, in order to convert this digital signal to analog signal, DAC, that is a digital to analog converter, has to be needed. That is to be referred for the conversion process. In this, there are a lot of techniques are available. Resistive ladder network, R2-2R ladder network, and inverted R2-2R ladder network. Let's have a R2-2R ladder network. So the basic components of the R2-2R ladder network are resistor and one voltage reference and one operational amplifier. So it is a resistive network with appropriate values and the switches, a reference voltage V reference, and the current to voltage converter is shown in this figure. So the switches in the circuit can be a transistor or a simple switch which connects the resistance either from V reference or to the ground. That is, the switch positions are controlled by the digital inputs. When the digital input logic is 1, it connects to the resistive network. When it is 0, it connects to the ground. Okay, so this is a simple operation. So the resistors are connected in such a way that any number of inputs, the total current IR is in a binary proportion. That is, this operational amplifier converts the current to the voltage value V0, which can be calculated from this equation. That is, V0 is equal to V reference into RF by R. That is a feedback resistor divided by this total resistor into your input values D2, D1 and the D0. So that is D2 divided by 2 power 1. D1 divided by 2 power 2 and D0 divided by 2 power 3 and so on. So in this manner, your digital value is connected to the corresponding analog value. So this is one part of information, how this digital value is connected to the analog value. Next, the important factor is resolution. That is the smallest possible analog value that can be represented by the n-bit binary code is called the resolution. Okay, for example, consider a 8-bit DAC with reference analog voltage 5 volt. Now the resolution of the DAC is 1 by 2 power 8 into 5 volt. That is, the 8-bit digital input can take 2 power 8 is equal to 256 values. So these are the basic information. Okay, so the time required for the converting digital signal to the analog signal is called the conversion time. So it depends on the response time of the switching transistors and the output amplifier. If the DAC is interfaced to the microprocessor, then the digital data signal should remain at the input of DAC until the conversion is complete. Hence, to hold the data, a latch is provided at the input of DAC. Okay, so next, AD558 can directly interface to the 8085 microprocessor bus, and it requires only two control signals. One is a chip select and the chip enable. Okay, so these are all the important informations. So this is a pin details of your DAC IC and the block diagram. So the IC consists of a reference current amplifier and the R2-2R ladder network and 8 high speed current switches. It has a 8 input data lines A1 to A0, A1 to A8. Okay, A1 to A8, which controls the position of the current switches. That is very important one. So the DAC 0800 can be this one. This one can be interfaced to the microprocessor through the 8-bit latch is shown in this figure. So the chip select signal from the decoder of the microprocessor system is delayed and inverted to the clock the latch. If the DAC is memory mapped, then the CS bar is from the memory decoder. If the DAC is IO mapped, then the CS bar is from the IO decoder. So the processor sends an address which decoded by the decoder in the microprocessor system to produce a chip select signal. So this one. Then the processor send the digital data to the latch. The buffer and the inverter will produce a sufficient delay for the CS to signal so that the latch is clocked only after the data is arrived at the input lines of the latch. When the latch is clocked, the digital data is sent to the DAC. So DAC converts the information, converts the corresponding information, and the analog value is ready for the output. So the DAC will produce a corresponding current signal which is converted into the voltage signal by means of operational amplifier. So the typical settling time of the DAC is 150 nanoseconds. So therefore the processor need not wait for the loading of the next data. So that's all about your DAC interface. So this is the overall block diagram of the DAC interface. So the chip select, after that automatically your DAC signal is enabled, and you can connect or you can convert your corresponding digital to analog data, and the value will be displayed. Next, ADC interface. So what is a ADC means? Analog to digital converter. That is, in many applications an analog device has to be interfaced to the digital system, but the digital device cannot accept the analog signals directly, and so the analog signals are converted into the equivalent digital signals. So using this ADC converter. In this, the quantization term is very important one. That is, the analog to digital conversion is a reverse process of the digital to analog process. So the A bar D is conversion is also called quantization, in which analog signal is represented by an equivalent binary data. Okay, so there are a lot of techniques are available. Successive approximation register technique, counter and a flash type converters. In this we will go for the successive approximation register converter. So here we are having a SAR register and one DAC and one comparator. So the conversion process is initiated by the start of conversion. Once the start of conversion is enabled, SAR register enabled, and it will sets the data. So automatically digital signal D bar A converter converts your corresponding digital value to the analog value, and it will be sent to the comparator. So the generated digital signal is converted into the analog signal by means of D bar A converter, and then it is compared with the given analog signal. So once it is compared, based on the comparator output, SAR reacts and it will gives the end of conversion signal. Once the end of conversion signal is over, and you can take the corresponding digital value. So this is a process of analog to digital converter using SAR register. Okay, so using ADC 0801, we are going to interface with the microprocessor. So the ADC can be interfaced to the microprocessor system through the tri-state buffer or port devices such as 8255 or 8155. So interfacing of ADC 0801 is presented in this slide. So it is a single channel 8-bit successive approximation type of A bar D converter. So it is a 20-pin IC. So it has a 2 analog input and both the analog inputs are used for the differential mode of operation. When the analog signal is single-ended positive, then Vin is used as a input and Vin is grounded and Vin is grounded. When the analog signal is a single-ended negative, then Vin is used as input and Vin positive is grounded. So in this way we are going to interface. So a typical circuit diagram for this interface is shown in this slide. The ADC is connected to the system bus through the tri-state buffer. Okay, the ADC that is a 74LS245. The ADC can be either memory mapped or IO mapped in the system. So the chip select bar is obtained from the address decoder of the 8085 system. Okay, so the conversion is initiated when both the chip select and the write bar are asserted low. So when the write bar signal, so here it shows a write bar signal, is used to reset the successive approximation register of ADC and to give a start of conversion. And the write bar of ADC can be connected directly to the write bar of 8085 microprocessor. Okay, at the falling edge of write bar, the SAI is resetted, and at the rising edge of write bar, the conversion starts. So this is a general procedure. So the end of conversion is indicated by asserting INTR, that is pin number 5 low, and this signal can be inverted to interrupts 8085 processor. So the processor reads the digital data using read bar, and when the data is read, the DAC will set INTR is high. So that's all about your ADC interface. Thank you.